Hey guys, Mr. B here again, bringing you another video, this time on the factor theorem. If you haven't seen my remainder video theorem, you might want to check it out. And that's because the factor theorem and the remainder theorem are very closely related. Really, the factor theorem is just a special case of the remainder theorem, when the remainder is 0. So if we have a polynomial p of x, so p of x, and we divide it by some factor, x minus a. So we've all seen these questions. You know, what's the remainder when you got a cubic divided by some linear factor x minus 2 or something like that. And you use synthetic division or you use the remainder theorem, you figure what the remainder is. Well, the factor theorem says that if you do this and you get a remainder of 0, then what that means is that this guy is a factor of p of x. So it divides into it, or it cancels it with some factor that's in p of x. Now another way we can think of it is, if we substitute p of a into p of x, then that should give us 0. So that's a really useful way of thinking of it as well. So p of a is actually equal to 0 if x minus a is a factor. So let's see an application of that. So where we use this actually would be the integral roots theorem, integral zero theorem, or rational roots theorem. And how you'd use it if you know, we've all seen questions like, really the factor theorem is the start of these things. If we have something like, you know, x cubed minus 2x squared plus 3x, let's go with something small, plus 6. So the possible factors of this guy are, you know, basically the factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So we want to find, you know, we'd actually try all these numbers to find a factor, you know, assuming that this guy didn't group. If we could probably group this one, but you know, you try all these until you actually got one of these equal to 0, and that tells you that's a factor. Then we'd have to use synthetic division, find a quadratic, so on and so forth. So that'll come in a different video. Sorry about that, guys. The wife's cell phone went off. Alrighty, so let's see this in a couple of simple examples. If you're looking for an application of using the rational roots theorem or integral zero theorem, just check out one of my other videos on it, and that'll give you a better explanation of this guy. Alright, so this is a typical question, usually a multiple choice question. It says, show x minus 1 is a factor of this guy. So all we really need to do is we have two choices, synthetic division, or we can use the factor theorem. So let's use the factor theorem. So if we go p of, remember, take the opposite number, p of 1, it should equal 0 if it's a factor. So let's try it. 1 cubed plus 4 times 1 squared minus 3 times 1 minus 2. So I get 1 plus 4 minus 3 minus 2. So that's going to be 5 minus 5, which of course is 0. So indeed, it is a factor, because we have basically a remainder of 0. Now let's see that with synthetic division. So, you know, obviously it's easiest to do it that way, but let's just prove and make sure that, you know, we're 100% correct. Maybe the question asks you, you know, do it with synthetic division. So we'd have, you know, we'd set up our 1 on the outside, and we'd make sure we'd have successive powers going down here, so we're going to go 1, 4, negative 3, negative 2, spot for our remainder, bring down our 1 times 1 is 1, 5, 1 times 5 is 5, add these two up, negative 3 plus 5 is 2, 1 times 2 is 2, negative 2 plus 2 is 0. So it still works with this guy. So if we wanted to write sort of this in a different form, now how we could write it, and this would be the beginning of, you know, using the integral roots theorem. This is our quadratic, x squared plus 5x plus 2, and then our factor of it is x minus 1. So this is factored one step more, so we'd have to think about, you know, what could we do with this one? Doesn't look like it factors, so if you're trying to find the roots, you know, the roots would be 1, what we have here, and then whatever you use to find the quadratic formula with that one. So check that out in another video, like I said before. Alright, so last question. So this one says, if x minus 1 is a factor of this guy, x cubed plus kx squared plus 3x plus 2, what is k? So we'd approach this the same way. So the key is this, you're looking for this, is a factor. So that means that p of 1 is 0. So if I sub 1 into here, it should equal 0. So let's see, 1 cubed plus k plus 3 times 1 plus 2 is equal to 0. So now I have to solve for k. So I got 1 plus k plus 5 is equal to 0, or k is equal to negative 6. So there it is. So that's your value of k. I like this question because it shows up a lot, and you know, it's useful for understanding the understanding the factor theorem. So I hope this helps, and if you got any questions, feel free to comment. Please subscribe. I'll talk to you guys in class. Good luck.